Hi everyone, thanks for coming. My name is Ashley, I'm an astrophysicist and a cosmologist. Today I'm going to be taking on a short journey through the local universe and explore some galaxies that are nearby to us and find out why these galaxies are dying. Kind of sad, but hopefully you'll be infused by the end of it. But before we talk about my favourite subject, we'll talk about my second favourite subject, which is myself. So I'm a PhD student at the Open University. I'm in my final year now, writing up my thesis, so I really should be home doing that, not talking to you guys. But my research is on the evolution of galaxies. So what has been happening over the 12, 13 billion years since the Big Bang to all of those islands of stars throughout the universe. And why am I here specifically? I'm a traveler. I'm pansexual, so the P doesn't even appear in the acronym, so I don't know what's going on there. And yeah, so let's talk about space. So if I were to ask a random person on the street to describe a galaxy, they will probably describe something that looks a little bit like Andromeda. Andromeda is a very typical galaxy. It's a little on the larger side of most galaxies, but in general, the shapes fall into all the normal boxes. It's sort of this flat disk, it has spiral arms, a big central bulge. But the truth is, Andromeda is just a typical galaxy, it's an average galaxy. And much like people, galaxies come in many, many different shapes and sizes. Some of them are straight, some of them are not. We have galaxies which are spirals and ellipticals. We have spheroids and irregular shapes that don't fit onto the spectrum. And thanks to a recent, I say recent, the past 2 decades, advances in digital astronomy, we've been able to study hundreds of thousands of millions of galaxies using big statistical surveys. And one of the things we're learning, you might be able to see from this image, is galaxies tend to come in 2 groups. There are red galaxies and blue galaxies. Now, the blue galaxies look like our typical spirals and disks. They have blue colours because their light is dominated by very young, very hot men and stars. And much like rock stars, these blue stars burn out very, very quickly. So after 100 million years, they die away and leaving all of the red stars. And the red stars are kind of boring, they just live for billions and billions of years. We don't even know how they died yet, because none of them have. And so as a galaxy ages, star formation begins to shut down. And galaxies transition from blue galaxies to red galaxies. And we want to understand the processes that are driving this transition from blue to red. So to understand that first, I need to very briefly describe to you how a star forms in the first place. So imagine a giant cloud of gas. That gas cloud collapses under its own gravity. It gets really, really small. Well, not really small. It gets to the size of a star and begins burning hydrogen in the fusion, and voila, the star is born. And these clouds of gas are really the vital component. They are the engine that drives star formation. And so by understanding the processes that remove gas from the galaxy, we can understand why star formation stops. So we generally split this. Again, I don't know what it is with astronomers and binaries, but we have 2 groups. stuff that's really driven by how big the galaxy is. The bigger the galaxy, the more likely this stuff is to happen. And so we're talking about supermassive black holes. You might have heard that every galaxy has a supermassive black hole in its center. And in the galaxy on the right here, you can see these two enormous jets that are blasting out from the center of the galaxy. And they are something like 200,000 light years long. This is an enormous stream of gas that's being blasted off the central black hole, just because it's really hot, and gases like to be really hot. And there's some really general relativity in there, but don't worry about that. Similar processes can happen with supernovae on a smaller scale, so when stars explode, they can blast the gas, heat it, eject it from the galaxy, preventing stars from forming. And then we also have sort of a not very well understood process, which is galaxy bars. For some reason, these bars disturb the gas, drive it to the center. Gas likes to congregate in a bar, much like gay people. And so it gets driven into the center where it's very, very hot. Again, hot gas can't form new stars. And then on the other end of the spectrum, we have the external stuff. This is the really cool stuff. These are the processes that are happening outside the galaxy, but they're affecting what's going on inside. And this is my favorite slide because it means I get to talk about harassment, stripping, and strangulation. So if you're wondering, a safe word is hub. So the galaxy on the left here is called the tadpole galaxy, so it looks a bit like a sperm. And you can see this stream of gas that's being stripped out from the galaxy. So it's had a close encounter with something of a similar size, and they haven't collided. As they passed each other, all of this gas and stars have been pulled out and injected into the interstellar medium, or the intergalactic medium, sorry. And where, again, it's just too sparse for any stars to form. So you remove all the gas from the galaxy. There's also rad pressure stripping, and I have to say, this galaxy on the right, this is one of my favorite images. This is apparently many of these things. You see 171 really bad things in astronomy. But you can see kind of this bone shape on this galaxy. And that's because it's moving very, very fast. Downwards in this image, so somewhere in this region, there is a giant galaxy cluster, and the galaxy here is moving down. And what happens is much like, I don't know if you've seen Tim Peake's return capsule downstairs. As it's moving very, very fast through the intracluster medium, the whole galaxy heats up because of the shockwave that forms. And you can see the black stuff in these galaxies, interstellar dust, and it's got these long tendrils that are being pulled out of the galaxy as they're slowed down by the intercluster medium. And so what you get again is all of this gas leaving the galaxy. And then finally we have strangulation. Now strangulation is when we prevent the galaxy from accreting new gas. So the galaxies are normally, because they're big gravity wells absorbing gas over and over, but there's some strange, not very well understood processes that prevent gas from accreting onto these galaxies. All of these processes combined begin to shut down star formation. Galaxies get strangled and harassed and they die. So to try and wrap all of that up for you, galaxies are not static objects. It may look like that, and that's because we only live for 80, 90 years hopefully, compared to billions and billions of years that these galaxies change over.